Hi friends, welcome to our new session. In this session we are going to discuss about the assembler directives in 8086. So in 8086 we are using assembly language, right? So assembly language are low level languages, right? Low level languages for programming the computers, microprocessors, microcontrollers and other ICs, right? So here we use symbolic representation of numeric machine code and some other constants that is used to program a particular CPU architecture, right? And usually this design is done by the hardware manufacturer. Okay, so before studying this assembly language, you have to know the assembler directives used in 8086. Okay, so what is an assembler directive? So assembler directive, it is a statement. Okay, it is a statement that gives direction to the assembler to perform some task in an assembly process. Okay, what is it? It is a statement that will direct the assembler to perform some task. Okay, to perform some task in an assembly process. That's it. Okay, and usually we have two types of statements in assembler. That is, we have two types of statements. That is, first one is executable statement and second one is assembler directive. Okay, so what is executable statement? Simple. Executable statements means instructions that are directly translated into machine code, okay, by the assembler. That is what executable statement. Then assembler directive means they are the statements that is used to that tells the assembler to perform some task. The task may be addition, multiplication, whatever. Okay, and or the task that is here you have to keep in mind that no machine language code is generated for assembler directive. That is no for this statements. Okay, that is no machine language code is generated for these statements. Okay, for these assembler directive statements. Okay, their task is to just indicate the beginning or a start of a segment, that is beginning or an end of a segment or a procedure or a program, or to reserve some storage for some storing some data and all that. That is the main task of what assembler directive. Okay, and we'll see some of the assembler directives. Okay, so first assume. See, first is assume. Assume is an assembler directive that is used in assembly language, that is used in 8086. So assume directive, it will tells the assembler that the name of the logical segment that should be specified in the segment. Here before that 8086 it works on 4 physical segments, right? That is one is code segment, second is data segment, third is stack segment, and fourth is extra segment. So here listen, the format of writing specifying the assume assembler directive is assume CS code. This tells the assembler that the name of the logical segment is code. Okay, name of the logical segment is code. Okay, and the instruction statements, and this in this code block, in this code segment, the instruction statements for the program contains. Okay, that is assume CS code means it tells the assembler that the name of the logical segment is code and it contains the instruction or statements for the program. Okay, for the program, and it is what? And it is a code segment. If it is a data segment, you can specify it as DS colon data. Likewise, so 8086 support 4 physical segments. So for defining the segments, you have to, that is the name of the logical segment. You have to, if you want to define the name of the logical segment, you should define the directive, thus assume. Okay, then second directive is DB. DB, it stands for defined byte. Defined byte means what? It will define a byte type variable, or it will store a byte type variable in a location, in a memory location. Okay, just one byte. Okay, just 1 byte. Define means you have to define, it will define a byte type variable. Okay, just example, sum db0 means what? The sum is the variable, right? Sum is the variable and it is initialized with the value 0. Initialized with the value 0. So you have to, this is the variable name, this is the assembler directive used, and the value to the variable, that is value is initialized as so in 0, the variable sum. So it will define a 1 byte of or it will store a 1 byte of memory. Okay, that's it. db. Okay, defined byte. Next, third is dw. Dw, it stands for define word. Okay, define word means it will allocate 2 bytes. It will define 2 bytes of storage. 2 bytes of storage. Here you see the store dw 100 dupe of 0. So here dw is an assembler directive and this dupe is also an assembler directive, dup. Okay, this means that 2 bytes of storage. 2 bytes means what? 16 bits, right? 16 bits. So dw 100, it will reserve an array. Okay, array. The name of the array is store. Name of the array is store. The size of the array is 100. That is 100 words. It can be store 100 words. And this array store, it is initialized with 0. It is initialized with 0. So this is smart. It creates it creates an array of name store and initialize the value. Initialize the array elements as 0. That is it. So it will create an array. It will create an array. That is, it will create an array store. Okay, and initialize with the value 0. Okay, initialize with the value 0. That is what dw. It is used to define 2 bytes. Then dd. It is double word. Obviously 4 bytes. So double word. So like this is used as dd. That is, dd is the assembler directive, and you have 2 words storage. That is, we can store 2 words by using dd directive. Okay, 1 2 3 4 5 6 7 8 here. 2 words of storage means 32 bits, right? Okay. Then dq. dq means card word. Card word means what? 8 bytes. This is 1 byte. This is word is 2 bytes, 4 bytes. This is 8 bytes. So 8 bytes means you can store 4 words, right? You can store 4 words. That is 1 2 3 4 1 2 3 4 1. You can store 4 words. Okay. Then next is dt. Okay, dt is 10 bytes. That is, you can store 10 bytes of storage to a variable. You can allocate 10 bytes of storage to a variable. Just like this d word 1 dt, then you can allocate 10 bytes of storage. 10 bytes means what? How many bits? 80 bits. Okay, so then dupe. I told dupe is also an what? dup. It is also a assembler directive. Consider list db 10. Okay, this means it will create a list. It will create a list of 10 bytes as a series of 10 bytes. Okay, it will create a list as a series of 10 bytes and initialize it with 0. Okay, initialize it with 0. So this is also an assembler directive. Okay, I have told this dupe in this example, that is for dw. Okay, that's it. Okay, next is segment directive. Okay, segment directive, it is used to indicate the beginning of a segment. Okay, here see code segment, right? Code segment. It is used to indicate the segment is a directive. This directive is used to indicate the beginning of a code segment. Okay, it is used to indicate the beginning of a code segment. So we will write code segment. Okay, then here you here you can see that is the segment. Here you can see ns. It is an assembler directive. ns. It is used to indicate the end of a segment. Here you see code ends. Here the code segment, that is the name of the segment. It is used to indicate the beginning of the segment, and it is code segment. A code end means what? That is the code. Here the code is ending. That is it is used to indicate the end of a segment. Okay, end of a segment. Okay, And this END, it stands for, it is used to indicate the end of a program. Okay, end of a program. There may be, that is there can be program, procedure, then segment and all that, right? I told that the assembler directive, the main task of assembler directive is to inform the assembler that about the start or end of a segment or a procedure or a program. Okay, so this is used to indicate the beginning of code segment, and the states and ends, that is the used to indicate the assembler that the end of the segment. Okay, segment is ending. And this end directive, it is used to indicate the end of a program. Okay, then you can see end P here. Okay, end P here, and before that there is also another assembler directive, that is for procedure. Okay, for procedure the assembler directive is PROC. Okay, for procedure. Okay, for procedure, PROC. Okay, so end P means what? End of procedure. Okay, end of procedure. Square root, PROC means it's a procedure for finding the square root. It is a procedure. And square root NP means that is the end of it. It is used to specify the end of a procedure. Okay, that is it. Then offset. Okay, offset means, example, move SI offset string 1. It means just simply substitute the offset address of any variable. Okay, you can directly substitute the offset address of any variable. Here you will see the SI will be getting, okay, SI will be getting the offset address of the variable string 1. Okay, SI will be getting the offset address of the variable string 1. That is it. Okay, this is it can be used as a directive for substituting the offset address of any variable. Then start, it indicates the beginning of a program. Okay, beginning of the program. Okay, that's it. Next is EQ. Okay, the assembler directive EQ. So EQ means it will tell the assembler to define a constant. Okay, to define a constant. See this example, factor EQ 03H. Okay, factor EQ 30. The constant name of the constant is factor, and it has a value 03. So EQ, it is used to define a constant. Okay, then by defining this statement, it should be defined in the beginning of the program. During the starting of the program, you should define this statement. Should be defined in the starting, in the beginning of the program. And you can use this in anywhere. You can use the statement anywhere in the program. Okay, that is, you can use anywhere. That is, add AL comma factor means what? Add AL comma factor means what? It will read it as, the assembler will read it as what? Add AL comma 03H. Okay, adds the AL comma 03H. So likewise, you can define the constants in assembly languages by using EQ directive. Okay, and you can use it in anywhere in the program, and you should define the constant in the beginning of the program, otherwise there will be errors. Okay, that is about EQ. Next is event bar align. Okay, so in this event bar align, event directive, it is used to increment the location of the counter to an even address. Okay, to an even address. It will if the address is not at the even address, if the address is not even, it will increment by using the key assembler directive even. We can increment the location counter to some even address, because if the address is even, we can read that is, we can access the memory, we can read the memory faster in one bus cycle. Okay, 8086 uses one bus cycle for aligned data. Aligned data means what? The address will be in the form of even address. Okay, address will be in the form of even address. And if it is at odd address, the 8086 will take 2 bus cycles. Okay, 8086 will take 2 bus cycles if it is odd data, and it will be an aligned representation. So during aligned data, it may take faster, that is, time is fast, that is, we require 2 bus cycles. Okay, we require 2 bus cycles to access the data, to access the data from the memory. Okay, so see this example, data segment. Say data segment, the name of the segment is data. Okay, it is used to indicate the beginning of data segment. Then sales db9 means what? It is an array of array name is sales, and 9 bytes storage is allocated. How many bytes? 9 bytes storage is allocated. Nothing is initialized because it is 0, because it is question mark here. Nothing is initialized. Okay, no values in the array, and we'll specify it as even. Okay, even assembler directive is used here. Before that, just assume that our segment is starting at 009 0009H. Okay, starting address is 009H. Okay, so this even takes this assembler directive, it increment the location counter. It increment the location counter to an even address. Okay, just even address means to next day. If the address is not even, here you look, the address is not even, so it will just increment it to a even address. So what does it? So the address will be what? 000 what? AH 000AH. Okay. So listen, then record dw100 dupe of 0 means it will create an array of name as record of 100 array, 100 words and initialize it with 0, and it will be the starting address of the array will be this. Starting address will be an even address. Okay, so that it can access the memory in one bus cycle. And finally the data ends means end of the segment. Okay, that is about the assembler directives. Some of the assembler directives in 8086. There are many other assembler directives. Just go through the I have listed out some of the main assembler directives that is used in 8086. Okay, thank you.